This
Okay.
conference will now be recorded.
Radhakrishna, can you please share me the screen? Can you please give me access to share my screen? Okay. So as of now, we've seen the logistic regression, right? Now we'll try to concentrate on the support vector mission. Okay. So from that one, I would like to show you a small project. Okay. So it's a very interesting topic and interesting project also. And so it could be easy for you to understand. But before that one, I just want to try to explain the support vector mission. Okay, that is also classification technique. So how the classification technique, how the SVM support vector mission, what it is? Support vector mission. So this is the technique, or this is the algorithm, which is the algorithm which is related to classification. I think you already know it, what exactly the classification. So if we have any kind of categories, then it can be categorized, right, or classified, right, with the help of this particular algorithm. Let me consider I have a data of the two classes. So the class A, it may be this is my class A. Okay, I have a class A data. This is my class A data. Okay, and I have the class B data. Okay, this is my class B data. Okay, so when I have these two classes, and these two classes, how we can able to classify with help of the support vector mission. So for that one, we have a hyperplane. Okay, we have a plane. So this is the plane. For example, this is the plane. Control jet. So let me consider this is my hyper. Okay, this is my hyperplane. So this is the hyperplane which is separating the two classes. What it is? This is my hyperplane. So why it is hyperplane? Okay, so the reason is that which is the plane which can be equally segregating these two classes. Okay, and moreover, this is hyperplane. It can be separated. It can be classified two classes. But by the time we have the one more marginal line, so the marginal line, it can be passes through. It can be passes through first vector. So this all are vector. Okay, so whatever the vector, it can passing through this particular margin, then this vector we are calling it a support vector. Okay, this is the vector. It can be passes through exactly a plane. Okay, exactly margin, then that that vector we are calling it say okay, support vector. And the meanwhile, we have to draw one more margin. It can be passing through one of the vector of the class B. Then this is the margin. This is the margin, and this one also margin. Okay, the distance between these two margins, we are calling it say marginal distance. The distance between these two margins, we are calling it say marginal distance. Two margin lines, it can be passing through the very closest vector of the classes. Okay, and this vectors we are calling it a support vectors. This is the way. So any two classes, we are going to be separated with help of the support vector mission. Okay, this is the thing it can be okay, but sometimes we can draw different hyperplane, different plane, different margins, and from that one, which is the exactly segregating, which is the support vector or hyperplane and margin lines exactly separated, and so that particular thing we are going to be considering the support vector mission. Actually, this is exactly the workflow of the support vector mission. Okay, so this is the thing we would like to solve a small program for more understanding purpose. And I just want to be open my Anaconda. Before I'm opening my Anaconda, I just want to show you the a small project. Okay. Okay. So careful observe here. This is my data. This data which is having the live biometric data. So we have the thumbs, right? So this is the thumb, live thumb images we have it. Okay, these are my images. Okay, this is my images. So this is image 1, and this is image 2, and this is image 3, and these images are live data, live images. These are the images, are the live images. Okay, and this is fine. And we have the data of spoop. So we have the one more biometric data, but the data which is a spoop data. Okay, so this is the images we have it. This is the spoop data. Okay, so this is a spoop biometric images. Okay, so we have the two type of images, two type of biometric data is there. One is the live data, one is the spoop data. Okay, so I would like to go for creating the model for detecting the which is the image or which is the biometric image is the spoop image, which is the image is the live image that I want to be determined, that I want to be classified. Okay, if I give some images in future, okay, so I would like to classify whether it is the live biometric data or spoof biometric data, that I would like to go for classify it. So that is my problem statement. Did you got understood my problem statement? See guys, we have the two type of biometric images are there. One is the live biometric data, one is the spoof biometric data. So our classification algorithms, what it will do, I would like to classifying the so spoof images and live images. Okay, so we have to create that kind of model. I hope you understood. If you not understood, please let me know. Are you following my point or not?
Yes, sir.
So I'm just launching my Jupyter notebook. See, so first step what we are doing now, first I would like to go for importing the all the important libraries for my project. Okay, actually by the time of implementing the project we are using some libraries, but after ending of my library I'm storing all libraries, I'm writing all libraries in the my first cell itself. Okay, so these are all my libraries. Okay, images, oops, np, maths and globe, matplotlib, pandas, scikit-learn, and model selection and transform. And I mean, if we have some images, that images we can transform into resizing and images reading. Okay, and converting into pickle. Okay, so if you are creating the model, then we can able to save that particular model into the pickle format, right? So that model only we are going to be using in a further, or we can able deploy into the okay servers. So that's fine. So these are the libraries we are going to be using in my project. So I just want to import it, so I'm executing that one. And one more thing here, I have the training data, I have the test data. For training also I have the live spoof data is there. For testing also I have the live spoof data is there. Okay, so this training data and the spoof data, I want to be read it, I want access that images. So for accessing that images, we have the globe function is there that I already imported in my first step itself. So here I just give the path for each one. So data is my current working folder. See, you just see this particular data. So this is the data, right? Within this particular data folder, I have the training biometric live and live. Okay, and we have a lot of images are there. So this is the path I'm giving, and dot star if I'm giving, then it gonna access the all images. Star in the sense before dot png, file name can be anything, but it could be dot png format. Okay, so it gonna read the all images, and that images data will be holding into this variables. These are my user defined variables. Okay, so this is the data I can resizing, and I would like to storing into the array format. Okay, so here the images we are opening it. See, for each and every for live so this is the variables which is having the all images. So this is the for loop. What it will do, this is the for loop. What it will do, it will taking the each and every image. That image we are opening that one, we're opening that one, and that we are converting into the gray square. And what we are doing now, which gonna division by 255. Okay, it is division by 255, and that too we are converting into the array format. This is the so whatever the image we have it, that we are converting into the array format. So each and every image we are converting into the array, and that arrays we are storing into the train live again, and train spoop. So spoop data also we are storing it, and we are converting into the array, and this test live and the test spoop data also we are converting into the array. So once you read all images and you are converting into the array format, and that images I would like to go for display. So before displaying that images, I just want to display the data of that images. So this is the train live which is having all images, each and every image data. So this is the entire data will be, this entire data will be for only one image. This whole data, this entire data will be only for one image. So this is the way we can display all images, but it's a huge data we have it, right? It's gonna take a lot of time, so that I'm displaying only one image data. And so meanwhile in a train spoop also I'm displaying the one image data, and from the test and test live and the test spoop also I'm displaying only first image data, and I'm just displaying the images in array format. Okay, that arrays format data I would like to show you in a image format. Okay, so I have plotted figure, and figure size is 10 by 8, and axis is we are going to off this one, and we are using m show and train live of 0 in the sense first image, and that it's a grace and interpol nearest one, and we are stopping this one. Okay, so this is the function, this is the small this is the small thing. What it will do, if we are going to displaying the, you're going to displaying this particular image. Meanwhile we can display all the images also, but we don't need it, just I'm showing it. So from this particular folder we are accessing this image and we are showing it. So our aim is that we need to go for build this particular model. But if you want to build the model, you should have the data, right? Data frame, right? But I don't have the data frame, I have the images. That images I can converting into the arrays, and arrays, and that arrays I can converting into the data frame. So this is the live directory, live biometric directory. This is the spoop biometric directory, and that is a training data. Okay, this is the training related live and spoop directories. Okay, this is my category, live category and the spoop category. So why I'm giving the live and spoop here, the reason is that you can see the last one is the live only. So this is the file, this is the folder I am considering as the one category, and spoop also it's another category. So I'm taking the two categories over here, and so this is the live is the last folder, and spoop also it's the last folder, and I'm joining. So whenever I value, so here the categories are only two. Whenever the category is the live, then the path could be, we are joining this directory, this folder, this path, and this category we are joining, and we are creating the OS path, and this is the path we are holding into the path variable. If in case my I value is not the live, it could be maybe spook, then else can be executes, and we are joining them. We are joining that spook directory and the last folder. And if we have the path, if we have the path and we are opening that particular path and you're reading the each and every image, and for, this is the for loop can be repeated. Okay, how many number of images are there in this particular folder, that many times this particular for loop can be repeated. For each time we're reading the one image, and that too you're converting into the 150 150 and 3 array format, and we are resizing this one. Okay, and that data we are storing into this list variable. And so this is the category is the live, right? This is the index is 0, so that category of index I'm storing into the this particular variable. So this is the way the internal for loop can be repeated. How many number of images we have it, that many times this internal loop can be repeated for the one category, for the live category. In the same way, for the swoop category also, this same thing can be repeated. Okay, so once if you repeated, this is the training list, this is the target list, which is having the image data and corresponding image name in a 0 or 1 format. So this is the training data and target data we are converting into the array, and with help of the pandas.data frame we are converting into the data frame, and we are creating the one new column, that is target column, and this target column which is having the target data. Okay, that means 0 and 1 only. So we are just displaying this one, we are executing this one, and this is the way you can loading the all the live directory, and we are holding into the training and target data. In the meanwhile, we are holding in the we are reading the whole spook data, and we are holding into the training and target, and that we are converting into the data frame format. Okay, and that too we are just displaying the first 5 records. Okay, and we are just displaying only first 5 record, and we have almost 67,501 columns are there. Okay, that means for one biometric, for one image of biometric which may requiring the that many features. From that one, the last column I considering the my target, that could be 0 or 1, 0 indicating live and 1 indicating that it's a spoof. Okay, clear? In the meanwhile, testing data frame also I can read it. So this is the way I may have the data frame of the testing, I have the data frame of the training. So if we have the training data, if we have the testing data, then I can able to build the model. Just a minute, guys. So we have the training data, we have the testing data, right? If you have the two data frames, if you have the two data frames, the last column I'm considering the y value from the training data frame. Last one I'm considering the comma dot minus 1, in the sense last column we are holding into the y train, and till last one, except last one, the entire data I'm considering as the my x train actually. In the same way, from the test data frame also we will do the same thing. Okay, this is the way. If we have independent data, if we have x train and if we have y train, if we have x test and if we have y test, then I can able to go with apply the model for it. See, careful observe here. In a support vector mission, we have the kernels are different types of kernels are there. From that one, very popular one is the linear, and next one is the poly, Okay, we have the next one is the poly. Okay, and third one is the sigmoid, and fourth one is the RBF. Okay, like this we have the different kernels are there in the same support vector mission. So for example, so kernel I'm considering, this is the SVC class, and we are already imported this particular class, and we are giving the kernel is the linear, and the C value is 1.0. Okay, and this we are going to be holding into one variable, and we are fitting your X train and Y train, and you are predicting the corresponding X train data. Okay, corresponding X train data. So this Y predicted, with help of this Y predicted and Y train data, we can calculating the training report. So if we have training report, everything will be like it's 100% only. That means whatever you training with that one, we are testing that one only, right? That was the reason we are getting the 100% accuracy. But I want to check with the test data. So that's the reason whatever I trained it with, whatever the model I created, CLF model, to this particular CLF model, I just giving the exit test. I got the corresponding Y predicted value, and this Y predicted and this Y test value, with help of this report, I just go and check the test report. So this is the way I can plot the classification report. I can display the classification report. It will take some time for reading this one. So this is the way you just see. Once it is done, I can show you guys. Okay, this is my training data. So this is the result of my training results. In the meanwhile, I can go with test report. This is my test report. Okay, see, for the test report I got very less accuracy when I compare with the training accuracy. Here everything will be like it's 100%, but here it is 82%. So I just check with the AUC curve. Okay, so I, from the matrices we have the plot ROC curve is there. To this particular model I can give you the my X test and Y test, and which is displaying the AUC curve. When it is the AUC curve which is approximately showing the 90%, that means my model is 90% is good. It's the only base of an accuracy, we can't conclude that, guys. We cannot conclude that the model is good. That was the reason I can check with another one. I can change my C value. C value now is 10. So with 10 also I can see the my AUC curve which is not changing. Even my model also, my model report also not change much. I can try with 100. Even 100 also I can get the same thing. So that I can change the kernel type. Instead of the linear, I can use the poly. When I'm using the poly, then my ROC curve and my accuracy also little changed. Instead of the 90, it could be the 91. That means my model is 91% is correct. Okay, and meanwhile I can try to change with the C value, and I can see the test result, and which is also 91%. Even the poly also not changing for different C values. Okay, now what I will do, I can try with the sigmoid. When I try with sigmoid, I can get the very less accuracy. So I cannot try with any other C values. The reason is that we are getting the very less accuracy. It's a very bad model. Okay. So now what I will do, I will try to change the RBF. Okay. Instead of my kernel is RBF, poly or linear, I can use the RBF. Whenever I'm using the RBF, see here, my recall accuracy, F1 score, everything was, it's approximately 99%, and it is 90%. Very good mode I got it. So even I see this particular AUC ROC curve, you just see the top one is line, some line is going on, right? You can see our previous AUC curves, which is not something like lines. There is some um, bendings are there, like little variation is there. Okay, but when I see the AUC ROC curve for the RBF for this one, and moreover the score is 97%, that means my model is 97% of accuracy I am getting. Okay, and meanwhile I can try with the C value is 10. So that time also not changing my AUC ROC curve. I can try with this values. Okay, even 97 only. Okay, now if, anyway, RBF is giving the best best model. But thing is that it's a till 97 only. I will try to make it some more. Is there any hyperparameter? If I do any kind of hyperparameter tuning, is my model performance can increase or not? I will try with grid search CV. So from this particular model selection, if I'm going with the grid search CV, okay, then I'm giving the different C values and different gamma values, and my kernel is RBF. RBF is giving the best one, so that I'm different C values and different gamma values. I am giving parameters, and that one I'm giving input for grid search CV, and I'm creating the SVC model, and these are the parameters I'm going to use it, and I can repeat this every one. And so I tried with, so it will take a lot of time to try to test with all this one. Okay, see, for different gamma values, different C values. Okay, and it was taking a lot of time also. Okay, and after that one, if I execute this particular grid best parameters and best estimators, then my C value is the 10 and my gamma value is 0.001, then I can get the best result score. So that grid predict exit test and classification report, if I see it, my testing data approximately 91% of accuracy I'm getting it. If I plot the AUC curve, then it's a 98%. Previously 97% only, right? So if I use the hyperparameter tuning, if I use the best parameter, maybe my performance will increase one more value, one more percentage. And with this values only, with this grid search report values only, I'm building the final model with the hyperparameter. After I'm doing the hyperparameter tuning, then if I go with these values, then I'm getting the best results. My AUC ROC curve is 98 percentage. Okay, so this is the way I'm going to concluding that this is my best model. Clear? See guys, I'm uploading this entire folder and the data folder and this Jupyter file, both I'm uploading into one Google Drive, and that drive link I can able to share with you, and you can I'm sharing with that Google Drive link. It is this file. Guys, I can share with that folder, and we can go through that particular folder and we can download it. Okay. Oh, okay. I'm creating the new folder. Okay, so name of the folder is biometric SVM. Okay, so with that particular biometric SVM folder, I'm uploading the upload folder. Folder upload, desktop. You just go on. I'm giving that link, and it could be shareable link. Upload. If I'm not uploading this data, it's very tough for you guys. Okay, and I'm uploading the file. This file also I'm uploading it, and I'm sharing this link to anyone. Only viewer and download it. Copy. So I'm sharing you guys. You can contact to the Radhakrishna, and that guy will share with you. Okay. One second. I'm uploading it. Copy link, and okay. Yes, guys, I uploaded. You just go and see it. Okay. Take care. Bye.